So once again, I really appreciate everybody for joining us this evening. Mount Madonna is actively integrating the United Nations Sustainable Development Goals. And the development goals were designed to build a global partnership and a coalition aimed at addressing a myriad of global challenges into our preschool to 12th grade academic program. The development goals really represent a blueprint for pursuing economic growth and innovation, social inclusion and equity, and environmental stewardship. And it helps us really mobilize all the sectors of society to work towards achieving these goals. Many of our alumni have gone on to become leaders, and their work is having profound impacts on the world. And we are featuring our alumni and friends who are working day and night to safeguard our environment and work to continue building a just and equitable future. This evening, Professor Noah Diffenbaugh, who is a 1992 graduate of Mount Madonna School, will discuss the complex climate challenges posed by the substantial benefits of energy consumption. He shares that while being very strongly with energy consumption, resulting in an enormous economic gap between low and high consuming populations. And this energy poverty creates tremendous exposure to climate related stresses such as droughts, floods, heat waves, and intensive storms. The fact that pathways for closing the energy gap are likely to result in substantial climate change via the emission of greenhouse gases also creates tensions between development priorities and climate policies. With the Sustainable Development Goals, the UN Paris Agreement, and the national and non-state commitments to net zero emissions within the next 3 to 4 decades, there is now ambition and urgency to transition to a low carbon energy system while simultaneously increasing energy supply and access and adapting to continued climate change. What is known and unknown, and how do all these simultaneously, how they will be discussed. So Professor Diffenbaugh is the Cara J. Foundation Professor and the Kimmelman Family Senior Fellow at Stanford University. He studies climate systems, including the processes by which climate change could impact agriculture, water, resources, and human health. He also serves as a lead author for the Intergovernmental Panel on Climate Change, the IPCC. On March 12th, Professor Diffenbaugh testified to the United States House of Representatives Committee on Science, Space, and Technology about the science behind climate change. He also holds many prestigious honors and awards. For instance, he was elected fellow of the American Geophysical Union, the AGU, and he's also the recipient of the James R. Holton Award and the William Kalla Award from the AGU, and has been recognized as a Kavli Fellow by the United States National Academy of Sciences. So this evening is going to be organized into 3 parts: the seminar by Professor Diffenbaugh, followed by a values style facilitated conversation led by Nicole Silva and Shannon Kelly, as well as all of our 12th grade students. And the last part is going to be questions from the audience. We also want to thank Monterey Bay Mortgage for sponsoring this event. And we certainly hope that you're going to come next Thursday to hear more from Tobias Aguirre, who is the CEO at Fishwise. So thank you so much. All right, without further ado, I am honored to introduce you to Professor Diffenbaugh.
All right. Hello, everyone. Thank you, Anne, for the very generous introduction. And it's great to see so many familiar faces. And I will confess that I feel much more nervous. I will.
Yeah.
I'm going to give you the rundown, hopefully convince you of what the abstract part of the introduction is correct. And I'm really looking forward to the discussion afterwards. So I'm really, it's really great that Mount Madonna School is focusing on Sustainable Development Goals, and you're getting a really comprehensive view across them from the different alumni and friends. And so I'm going to focus on the climate part of the Sustainable Development Challenge, but I want to emphasize, climate's really big, but I still will look at it through tunnel vision tonight. So I'm glad you're hearing about the rest of it from others. And this is a picture, it's about a decade old now, but it's a picture taken at the airport in the capital city of the Republic of Guinea. And these are college students, and they don't have electricity in their homes. And so there's this daily migration to the airport to sit on the bollards underneath the lights in order to study. Right. So this, to me, really crystallizes the challenge that we face with sustainable development, and in particular the climate aspect of sustainable development, because climate change is a side effect of primarily of energy consumption, but it's a side effect of human activities. It's a side effect of human activities that are essential for well-being, and this photo is a reminder of that. So the punchline is that the challenge is really that we, I often get asked, well, about stopping climate change, or in the congressional hearing that Ann mentioned, there was a question about, like, how low can we get the CO2 concentrations? Can we go back to pre-industrial, or can we get to 350? And that is not practical, for one thing, but it's also, from an equity standpoint, it really is unrealistic. And from an ethical standpoint, we can discuss that as well. So really, over your adult lifetimes, if you're a Mount Madonna School student now, over your adult lifetimes, your generation is really going to face 3 grand challenges simultaneously. And I want to touch on each of these briefly tonight. And again, I'm looking through the climate lens, and you get different lenses from different of the guests. But your generation is going to have to, the world will have to increase energy supply and broaden access. The world will have to decarbonize the global energy system in order to stabilize at any level, whether it's the Paris, the ambitious goals set in the Paris Agreement, or any other level of global temperature. And we're guaranteed to have more climate change than we've already had. So we're going to have to adapt to continued climate change. And each one of these is really a grand challenge, and doing all 3 simultaneously is super wicked, as others put it. So first, why do I say the world will have to increase energy supply and broaden access? We do not supply enough energy globally to ensure human well-being. There are lots of different statistics that support that statement. But these are some of them. So you'll see different figures for clean water. About 1 billion people without clean water is, if I'm sure that if anyone in this Zoom walked up to the water that the next billion have access to, we would not consider that clean as well, right? So there's certainly 1 billion with very unhealthy water, and another 1 billion without modern improved water resources. Cooking, is about 2.5 billion people that rely on biomass for cooking. This is the leading cause of environmental health effects. Morbidity and mortality is from cooking in an enclosed space with biomass, mostly dung and wood. More than 1 billion people without electricity, and very well how fundamental that is, not considering the Zoom world, but just for just the baseline human well-being. Transportation, a colleague of mine, Jenna Davis, who's in the Civil and Environmental Engineering Department and in the Woods Institute with me, same institute that I'm in, her research group has done research on the amount of time and energy that it takes, calorie demand of gathering water, for example, in East Africa. And so on the order of 6 hours a day, mostly women and girls spend collecting water, as you see in the photo. So that's both the lack of improved water resources and lack of transportation, right? I mean, huge opportunity costs. And then a lot of what I study is vulnerability to climate stresses that we know comes with having, addressing that vulnerability, creating resilience requires a lot of energy. And for most of us, we have that in our baseline that we rely on. So how much energy does the world need to supply? This paper is about a decade old, and I just plotted other people's data. But this is each of these is a country. And on the horizontal axis is the per capita energy consumption. On the vertical axis is the Human Development Index, which integrates, it's a measure of human well-being from the United Nations. It integrates not only wealth, but also metrics like literacy and child mortality and life expectancy. And you can see that they're very steep, and then there are fields of research in trying to understand this relationship. But there's just at the first order of just making the scatter plot of the data, right? There's steep increases in human well-being at very low access to energy, and then there's I'm out here somewhere, right? But I just got a fifth car, so I've probably moved over here. People perked up like I was joking, but no, we actually have 5 cars. So this is all luxury consumption, right? And you can see that when I made this plot, 15% of the world's population accounted for 85% of the global CO2 emissions, right? And this is all to the right of this vertical line. So this is not. I am not getting improvement in fundamental human well-being with my 5th car. And we can ask again, for this first grand challenge that I mentioned, like how much energy do we need, right? So if we're getting close to 8 billion people now, well past 7, and a world, projected for 9 billion people mid-centuries, 9 billion people living, right around this vertical line, which happens to be Japan's per capita energy consumption. It's right at the bottom of the OECD countries, and that's 3 times the current global total energy consumption. And a lot of scenarios you'll see will say double the energy consumption. And the point I want to make about that is that assumes that a lot of people still don't have access to modern energy resources, right? So double the energy consumption by mid-century is probably more realistic in terms of what the world will be, and that means that's because the world will is likely to remain very unequal in access to energy consumption, access to modern energy resources. But if we wanted a world where everyone at least had the minimum of the OECD, that's 3 times what we are supplying globally now. That's a huge challenge for the coming decades, all by itself, how to do that, particularly broadening access. But if the world is going to stabilize the climate system, that will require decarbonizing the global energy system. So that reaching net zero by 2050 is the stated goal of the current presidential administration. It's the stated goal of the EU, stated goal of the university that I work at. There's lots of stated goals for net zero by 2050 now. Why is that the goal? What does net zero mean, and why is it necessary? So these are the historical carbon dioxide, fossil fuel emissions since I graduated from 9th grade, which used to be graduating junior high at Madonna school. High school didn't start till 10th grade back in 1989. So that's where I was starting high school at Mount Madonna, back here when this plot started. Sorry, the Soviet Union is breaking up as well, which you can see that dip in the record. Here's the financial crisis of 2008, 2009, 3%, we were up 3% per year growth rate in the first decade of the 2000s. We had a financial crisis and then rapid rebound, and then debates about whether or not emissions were peaking, and then, as I'm sure you're aware, a steep drop in emissions during the pandemic. Although, as a side note, I'll say, if I've had people say to me, well, doesn't this prove that we can do it? We just have to stop using so much. And I mean, you all know, we are not at Mount Madonna School having this event right now. We're on Zoom. You all know how much everyone has sacrificed, and that austerity has resulted in on the order of a 5 to 7% drop during the pandemic. So austerity is not going to get us to net zero, and whether or not we'll see what the trajectory is going forward, but you can see that we are very, very far from net zero emissions. So why do we need net zero emissions? It's because of the fundamental energy balance of planet Earth. And when I say need, I just mean to stabilize the climate system. Why do we need net zero emissions? We are seeing increases in atmospheric carbon dioxide concentrations and the concentrations of other greenhouse gases in the atmosphere as a result of the human emissions. And we have a very clear chemical signature of those, the human fingerprint of those emissions in the carbon that's in the atmosphere. But we're getting a tremendous natural service from the ocean and the trees and soils, because less than half of what we've emitted has actually stayed in the atmosphere. It's around 44% of the CO2 that humans have emitted has stayed in the atmosphere, and the rest has gone into the ocean and the land surface. And as you can see on the bottom, the ocean, the partial pressure of CO2 in the surface ocean is going up, the pH is going down, and that's called ocean acidification. Right? So we are seeing the impacts not just in the atmosphere, but we're seeing it throughout the Earth system. And we're seeing it in the global temperature. And so the global temperature is going up. We've had about 1.1 degrees Celsius of global warming over the last century, which you can see from this graph. And the zero value here is the mean from 1951 to 1980, and each of the years is plotted as a departure. So we're now getting years that are more than a degree Celsius above that mid to late 20th century baseline. And correlation does not imply causation. And I'm a little worried about the time. So there's this great, should I do it? Okay. Last time I did this, I tried to show this in class and this quarter, and the Bloomberg website said I needed a subscription, which I refused to pay in the middle of class. And so what's the problem? We'll see if it works better. Okay. All right, so can you see this Bloomberg Business Week? All right, so here are the same. So how do scientists go about understanding the relationship between those human emissions of greenhouse gases and the global temperature in the climate system? So we use climate models, and usually when I talk about this in class, I talk about how when I was at Mount Madonna School in elementary school, we in science class, we did an experiment where we grew corn seedlings, and we did a controlled experiment. So we had 10 or something all in the same pot, probably the bottom of a milk carton from the CB. And we put exactly the same soil in each one of these milk cartons, and we put exactly the same corn seeds from exactly the same source container, planted them each of the little pots of soil, and we put half in the this is in the farmhouse actually, literally we put half in the closet and half in the window in the farmhouse. And everything was controlled except the sunlight, and the ones in the window grew and the ones in the closet did not. Was it the soil? No, the soil was identical. Was it the water? No, we were very careful. We watered them all exactly the same. Everything was the same. We did a controlled experiment, right? And so I spent the rest of my career repeating that third grade experiment. I don't know if Leela's on, but I did in 8th grade, I did a microwaving corn plants experiment. Now I use climate models to run basically the same experiment. We'd love to run that kind of experiment on the global climate system, but we are unable for obvious reasons. So we use climate models to run that experiment. So essentially, I'm going to show you what the climate models predict the global temperature would be with different treatments. Just think of this as like watering some plants and not watering others, putting some plants in the window and not others, giving, fertilizer to some and not to others, right? That's essentially what we do with the climate model. So here's the same data from NASA that you've already seen. So we can take these climate models and run them just by varying Earth's orbital parameters, right? Because this, as we know, this has been the pacemaker of the ice ages going back millions of years. So maybe it's Earth's orbital parameters. So you can see, hopefully there's a dark line is the mean of the different climate model simulations, and then the dots are the 95th percentile. So no warming. Warming is well outside of the confidence from the orbital changes. Possibly solar variability. It's the sun. Biggest source of energy to the Earth is the sun. Sunspots. No warming from the sun. Okay. Volcanoes. When I was in Pinatubo, okay, there's Pinatubo. I was there in 1992. I was in high school at Mount Madonna. I went to Mount Madonna. I'm not sure if you're aware. I'm class of 92. Santa Cruz County Boys Volleyball League champions. All right. Pinatubo, amazing sunsets off the deck of the CB. You could not believe the sunsets off the deck of the CB in 1992 from Pinatubo. Just tremendous sunsets from the aerosols in the atmosphere. Lasted cooling of about 1/3 of a degree Celsius, lasted about 3 years, did not cause global warming. All right. Maybe altogether, maybe there's some nonlinear, it's a complex system, non-linearly they all make warming. No, not that. Okay, all right, this is, I can tell, even on Zoom, I can tell this is getting old. Okay, land use, land use is cooling, sorry. Okay, ozone pollution, maybe, no, not that either. Are we ever gonna get anywhere with this? Aerosols, okay, aerosols, we can all see them. Ooh, cooling, interesting. This happens to be called the solar dimming and the masking. Turns out masking of global warming from the aerosols. All right, greenhouse gases. Okay, wait, greenhouse gases. Come on, mouse. Okay, maybe the greenhouse gases. Oh, interesting. All right, warming, maybe. Case closed. Well, not really, right? Actually, too much warming, more than what we've actually had. Maybe these all add up. All the human factors. Huh. All right. Pretty close. These climate models are pretty good. And gets the long-term trend, doesn't get all the wiggles. Maybe if we put all of them together in the climate model simultaneously. Okay, even Pinatubo. Simulated amazing sunsets. Okay. All right. So there is the short version of our evidence for the attribution of global warming to human activities. And I spent a lot of my time doing that, not with the global temperature, but with regional climate changes, and particularly in the last, a lot of my time in the last almost decade now, it's been on extreme events, trying to understand extreme events, basically using that same approach. Okay, so if I'll try to pick up the pace here. Thank you, Bloomberg. I should run for president. Okay, so, oh, what happened? Okay, so why do I say we need to decarbonize the energy system? Why not just get back to our emissions back when I was in high school? Maybe that would be enough, right? And the reason is that we have very high confidence that the global scale warming is proportional to the total cumulative emissions. And I'll spare you the details, but this figure, the first version of which was published in 2009 by Matthews et al., really changed the international climate negotiation landscape. Because what it showed was that basically there's a budget of total emissions for different levels of global warming. And what you see in the black are the historical, you've already seen actually both of these data sets of you've already seen the emissions and you've seen the global temperature. So that's just plotting them. But this is total, adding up all the emissions, just adding up, going to the right, every ton of emissions getting us further to the right. And then the global temperature you've already seen. And then out on these, the colors are different scenarios of future pathways. And these are wildly different futures in terms of the annual emissions trajectory, but they all line up really, really robustly to create this linear relationship, the slope of which is somewhat uncertain. And the aerosols that we already learned a little bit about are a big reason why this is uncertain, as well as the uncertainty about the climate sensitivity of the global temperature. But essentially, we get about a degree of warming for every 500 billion tons of carbon in CO2, about every 1,800 billion tons of CO2 that we emit. And so essentially what the UN Paris Agreement does is it says, okay, what is the countries agree that 2 degrees must be avoided, right? Not to exceed 2 degrees. And if you were working as a climate analyst and the UN said, all right, we agree 2 degrees will not be avoided. What's the maximum we can emit to guarantee we don't reach 2 degrees? You can just draw a line, green line right here, right? And you've got your number, right? You can't enter this salmon colored plume to be 100% certain that you'll avoid 2 degrees C, right? So if you see where we're at, right, there's your budget for 2 degrees C. So I kid you not, and here's 1.5, by the way, and it's tough to see because it goes right over where 2020 is. So there's some implications there. We do not have 100%. We are past the point of having 100% certainty that we could avoid 2 degrees C. Sorry, 1.5. We still might avoid 1.5, but we're in the plume. And when you hear things like we have 12 years left, or we have 11 years left, or we have 10 years left, maybe next year you'll hear we have 9 years left, something like that. It's coming off of this graph. I'm not joking. All right. And how close are we to reaching net zero emissions, right? If we're always, as long as we're emitting, we're going to keep moving to the right, keep getting more global warming. We need to decarbonize in order to stop the global temperature from increasing. How close are we? Well, we're providing around 6,000 exajoules of energy per year globally, and about 85% of that is coming from fossil fuels, right, that emit carbon dioxide and other constituents to the atmosphere. Right? So coal, natural gas, oil provide around 85%. That biofuels is still almost 10%, right? And recall that cooking with biomass in an enclosed space is the leading cause of environmental health problems. Lots of people get sick and die from that. So there's another piece of the pie that from a sustainable development perspective is a big concern. So we have a small piece of the pie that right now that is not is non-emitting energy sources. The MIT Technology Review had an article recently or a couple years ago, where they ask the question, if we just keep doing what we're doing at the increasing these pieces of the pie at the rate at which they're increasing, how long will it take to decarbonize the energy system? And the answer is almost 400 years, but less than 400 years. It will be less than 400 years, but like more than 380. So that's a challenge, right? And here's another way of looking at that, right? Here's all that 85% plus the land use change, and where is the reaching net zero by 2050? There we go. All right. So my university says we're going to reach net zero in our endowment and our operations by 2050. Biden administration says the US is going to reach net zero by 2050. I don't know what Mount Madonna's goal is. But that's a steep decline, and it's not the direction we're headed, other than with COVID. So I'm not saying austerity is the answer. Okay, that's 2 grand challenges. Now's when the hope really starts to bubble up. So get ready to feel hopeful, because we still have a 3rd grand challenge to go. So why did I tell you that we have the grand challenge of adapting to continued climate change? That's because we're not adapted to the climate change we've gotten from all of these emissions, and we're going to have more climate change even if we somehow get down this cliff to net zero by 2050. That's still going to give us, something on the order of twice as much climate change as we've already had. Right, 2 degrees is twice what we've already had. So we are going to have to adapt to continued climate change. And why do I tell you that? Well, there's a couple ways to measure it, and I'll try to be quick. What does a world of global warming of 2 degrees or 4 degrees look like? I don't live in the global mean, although I do live in all of us who live in the Bay Area live in a place that actually our temperature is pretty close to the global mean, but we all live where we live, right? And there's a lot of variability, and in particular, the mean isn't what we feel, right? We really feel the extremes. And so a world of 4 degrees of warming, right? Basically to continue the trajectory we've been on, right? Everywhere that's red here, the gray, 90 to 100% of the seasons, in this case is Northern Hemisphere summer in the Northern Hemisphere, 100%, we're stark red, basically 100% of the seasons, 100% of the summers are hotter than the hottest summer of the late 20th century. And so that's even the coolest summer being hotter than the hottest one, say, when I was growing up. So 2 degrees reduces that a lot. That's good news, right? But still, even here in the US, still, 50 to 75% of the summers are record hot summers. If we look at the tropics, even at 2 degrees, right, there's still areas where, in the mean, 80% of the summers are record hot summers. And we've done other analysis that has shown that there's a real chance that at 2 degrees, that a lot of these areas are also in unprecedented, permanently in an unprecedented heat regime. Sea level rise is also happening, and we're also experiencing impacts. And there's a big difference. This will take a long time. This will take millennia. But when scientists look back at paleoclimate periods of similar temperature of what we have now, or even of 2 degrees warming, certainly 4 degrees warming, sea levels were much higher during those periods in ancient times, and it'll take millennia to melt all of this, all of the ice that you see as the blue is ice and the brown is not. And so if we meet the Paris commitments, right, we're still looking at a lot of sea level rise on millennial timescales, and potentially by the end of this century. And if we burn all known fossil fuel reserves, then on 10,000 years from now, a whole lot of Antarctica we can expect to be melted. So that's a lot of sea level rise, and there's a whole suite of impacts. And I think with respect to the Sustainable Development Goals, some of the most important are on poverty, and in particular on impacts on economic growth, particularly in countries that are already hot. And this is research that my colleague Marshall Burke and I have published. So if you look at the bottom map here, all of the dark, I don't even know what color that is. The darkest reddish color on this map, magenta, I don't know. These countries all have, you know, pretty much 100% probability of having higher per capita GDP at 1.5 degrees of warming than at 2 degrees of warming, right? So in particular for the poorest countries in the world, and we've done, you know, calculations, you know, it's very large, you know, something like 75% of the world's population lives in countries that have at least a 75% chance of having higher per capita GDP if the world reaches 1.5 degrees than 2 degrees. So it's a really big issue for the Sustainable Development Goals. And I'll just close by saying, you know, a lot of my work in recent years has been on extreme events, as I mentioned, and this is an area where when I started graduate school in the Y2K era in September of 2000, you know, we basically, anytime you saw a scientist speak in public about an individual extreme event, the answer was some version of "we don't do that." You know, it was, well, we can't attribute any individual event to global warming, or you're talking about weather, we're talking about climate, or something like that, right? And over the last 15 years, particularly over the last decade, there's been a huge revolution in our ability to answer questions about individual extremes. So that's a lot of what my work has been in recent years, and we're at the point now where we can you know, pose hypotheses in a rigorous way, and, you know, test them in pose hypotheses that are scientifically tractable, and test them in a rigorous way, and have a neutral position on them, and see what the answer is. You know, so that's been a lot of my focus with my research group and collaborators in recent years. So I think I'm supposed to. I was told by a consultant once, when I gave a TED talk. I was told by the TED talk expert that it has to end in hope. So there is hope! Exclamation mark. That's the large font, red color, and then in the smaller font are some things that might give you hope. But this is the list. My congressional testimony was mentioned, so this is literally the list. In my invitation letter, the chair and ranking member asked me to comment on research priorities for the U.S. For climate science, and so this is literally my list from that. So that was being recorded. It's all there now. Okay, but this is where I want to close. So this is, I mentioned Jenna Davis, right, who does the research on. She does a lot of. She works on health and sanitation and sustainable development, and would give a much more compelling talk about the Sustainable Development Goals than I have. But all you'll get from her is the calendar outside her door. And this really gets to the heart of it, right? You hear a lot of one weird trick kind of. You see a lot of headlines like, oh, well, here's the one thing, if you just need to know one thing about solving climate change, it's this, click here, right? And the reality is if there was an easy answer to climate change, we would be doing it, right? This is a big challenge. It's a big challenge because I'm sitting in a room with, you know, on Zoom with a monitor, and, you know, I mean, just kilowatt hours of energy, and that's doesn't even count my 5 cars outside, right? I mean, we just get an enormous amount of benefit from energy consumption, and as much of it is as wasteful and as luxury. The bottom line is that there are billions of people that do not have access to modern energy resources, and sustainable development, what is really required is you know, addressing the imperative of ensuring that all humans on planet Earth have access to the fundamental resources that are needed for human well-being, while minimizing you know, the climate change that happens, and more broadly the impact on the environment. So I will stop there, and I look forward to the rest of the discussion.
All right, well, thank you so much for such an interesting presentation. As a part of our Science with Humanities class, the seniors have prepared some questions for you. Thank you for giving us the time to ask our questions, and we're very thrilled to have this opportunity. So I'm going to hand it off to the first question haver.
All right. Hi, I'm Octavio. Yeah, my first question is, in your article, Earth's Future, Doubling of the US Population Exposure to Climate Extremes by 2050, you state, our results indicate a doubling of overall exposure to extreme conditions, with the strongest increases in the Western US and parts of the Eastern US. How much of an impact does the acceleration of renewable energy-based transportation have on preventing the devastating impacts we face with extreme weather and climate change moving forward?
Excellent question. I'm remembering that paper as you ask it. Yeah, so that paper was focused on 2050, and I will spare you, I won't go back to my slides. If we were in class now, it would be, you wouldn't be so lucky. My course evaluations comment on how much I search around for files on my computer. So in 2050, if you recall that, plume diagram I showed of the cumulative emissions and the global temperature. So the short answer for 2050 is that if say this goal of reaching net zero emissions by 2050 is achieved, that gives us a pretty good chance of staying below 2 degrees Celsius of warming globally. And so that's that world in which, say, here in the US, the summers are, record hot summers anywhere from 50 to 75% of the time. And in the tropics, a real shot of being, hotter than any of those people or ecosystems have been exposed to historically. And there's a good chance that that's not quite as severe as if we don't reach net zero by 2050. But the point is that there's a lot of global warming and climate change locked in. And so part of what is difficult for a lot of the students in my class to sort of get their heads around, and I know from public polling a lot of, say, Americans to get their heads around, is that both of these are true simultaneously. Like we are going to continue to experience intensification of climate stresses. And the more we emit, the more the greater the intensification and the more rapid the intensification. But we are not, in our lifetimes going to go back to the climate of, when I was born, even, let alone when my parents or grandparents were born. So both of these are true, right? It's decarbonizing. You asked about electric vehicles, right? So decarbonizing the transportation sector is that's like a third of the U.S. emissions are transportation sector. So it's a huge part of the greenhouse gas pie. It's a huge part of the air quality pie. So it will have a big effect on our emissions trajectory. And my group had a paper this summer on wildfire risk in California, and we showed for that time frame that you're asking about for wildfire risk in California, like we will have less intensification of wildfire risk in California if we reach net zero by 2050, and we will still have more wildfire risk than we have now. So both of those are true.
Hi, my name is Killen, and I have the next question. So You spoke about mitigation and adaptation strategies in the Science Behind Impacts of Climate Change Crisis hearing on March 21st, 2021. What forms of mitigation and adaptation would suit California best, especially considering we are in the middle of a drought and with our agricultural importance to our community and the world?
Yeah, another great question. So I think, yeah, so when I was in graduate school and even in my first faculty job at Purdue, right? So all through the early 2000s, I think, there was a real credible argument between, the cost of mitigation, meaning reducing greenhouse gas emissions, and the cost of adaptation. There were a lot of credible arguments, and I even may have been one of the people making some of them at some times, that for a lot of parts of the world, that economic growth would accelerate the resources that would be needed for adaptation, and that and there were a lot of I'll just say there were a lot of economists arguing that mitigation, that adaptation, it would be optimal to wait and see what climate changes happened, and then invest resources in adaptation. And what we're seeing now, really clearly, and partly from the cost of the extreme events and our ability to quantify the contribution of historical warming to those extremes, and then work that my group and other groups have done to quantify really the contribution to the dollar costs of different kinds of extremes. What we're seeing is that adaptation is really expensive, that we're not adapting, and we're paying a lot more than we would have otherwise. And so I think that the conversation has really changed in the last decade from, in terms of, sort of, if you ask an expert what costs more, mitigation or adaptation, I think it's pretty clear now that adaptation costs a lot more. And that I haven't even mentioned equity yet, right? So that's like in the really, let's just say, sort of neoliberal, and I'm saying that neutrally, just factually, kind of neoliberal optimization viewpoint. When we look at equity, it's absolutely clear that that poor and marginalized communities are more exposed and more vulnerable to climate change, not just in the future, but to the climate change that's already happened. They're also much more exposed to pollution from the current energy system. And so, this is really, it has become very clear that really this is not an issue about the future, and the arguments about mitigation and adaptation are not about the future. We're experiencing not just the risks of climate change now, but we're experiencing the sharp end of the spear, as Catherine Mock puts it.
Hi, I'm Sammy. My question is, you've dedicated yourself to spreading awareness about climate change and combating it. One problem we are facing in the United States is that climate change and science as a whole is increasingly politicized. How can we make climate change a non-partisan issue?
I'm not an expert in that. Yeah, so I'll tell you my approach, and I know we're being recorded. I guess I've said it. I said what I'm going to say being recorded before, and I got some backlash for it from colleagues. So there we go. I'll do it anyways. Yeah, so my approach is, I think there are it's fact that there are very few people who really understand the evidence of climate change, who are also in a position to be in the conversation about, where decision makers are asking them questions, right? And there are a lot of advocates, and I think that for me personally, I feel pretty lucky to be when I have the opportunity to be able to answer questions from decision makers, that preserving that role is really important. And I know for a fact, I know from firsthand experience and as well as peer-reviewed research, that when experts are prescriptive, then their credibility is reduced. So one anecdote that I think about that, given the performing arts emphasis at Mount Madonna, maybe it will be more effective than the last time I made this point in a recorded panel. So I heard an interview with Meryl Streep once, and Meryl Streep was in Prairie Home Companion with Lindsay Lohan. I don't know so if you don't know who Meryl Streep and Lindsay Lohan are, you don't need to know what a Prairie Home Companion was. But anyway, so Lindsay Lohan was having this very public meltdown, I think is the technical word. And I heard an interview with Meryl Streep, and she said, like, you can't, like, to be credible as an actor, the public can't know much about you. And she said, I Meryl Streep, and I'm paraphrasing here, I'm sure I'm not quoting correctly, but she said, like, I have to be able to be this role and be completely believable in that role. And then I have to go to the next role and be completely believable in that role. And the more that the public knows about the person, the less credible the actor is able to be. And I am not suggesting that I'm out faking it or playing a role or something, but I think it's true. I think it's true of those of us who are doing research that's policy relevant, that in order to be credible to all of the decision makers, advocacy for a particular outcome makes it very difficult to remain credible as a source of objective information.
Suresh, I wondered if we could have one more student question, if you have time for that. And then,
oh yeah, no, I can. I talked for more than the allotted time with my PowerPoint. I can stay on. I have nowhere to be outside of my house.
And then afterwards, we'll start with our audience questions as well. So the next student, please.
Hello, I am Untitled. So today's developing countries need to strengthen their economies in order to survive in today's world. How can wealthier nations support developing countries switch from cheaper fossil fuels to better but more costly green and renewable energies?
Great question. And the answer to that question has changed quite a bit in recent years as the cost actually has become a lot more similar. So coal is essentially being made obsolete by market forces. And, I think that the usual answer you'll get to this question, which I think is the right one, is that there's a lot of inertia in the technological development life cycle that we took here in the US and in Europe, right? And so the key in terms of just the total, and when I say the key, just like the total, the grand challenges that I I framed for you, right? In terms of ensuring energy access, decarbonizing the energy system, and adapting to climate change, the key is leapfrogging technologies, right? And not developing along the same pathway that we know has worked, because that's how the US and the EU and Japan and the OECD developed historically. And I was lucky to go to India when I was growing up, and so the story you'll hear a lot, and I experienced the first half of the story firsthand, right? When I went to India, I guess the first time in 1987, right? Like there was like one landline within, one landline in Hardwar, and and there were miles and miles and miles to the landline, right? Like, and someone can unmute, my mom or dad or whoever can unmute and tell me exactly how many landlines there were in Hardwar. But the point is that then like they didn't go through the telephonic development stage and everyone get a landline and then everyone get a cell phone. Like they leapfrogged lots and lots and lots and lots of people, leapfrogged landlines and went straight to mobile. And so that's really the key, right? Is ensuring, number one, ensuring the modern energy resources, and in doing so, for the decarbonization challenge, it will require that those energy resources are provided with with non-emitting energy sources rather than taking the fossil pathway. And the good news is that we know that countries like China and India and Indonesia actually are decarbonizing a lot earlier in their development pathway than we did. So that's the good news. My mom, I don't know if you guys know, on Zoom you can direct message. So here's one from Sharda Diffenbaugh to me saying, we ordered 5 landlines for the ashram school and they never came. So there's proof. That is proof of leapfrogging. Proof of leapfrogging. So we can order 5 coal-fired power plants and see if they come.
Okay. So I've been in Mount Madonna for most of my life. I came in kindergarten and stayed all the way through. It's impacted me, especially the way I treat the environment and my efforts to be environmentally conscious. So I'm wondering, how has Mount Madonna affected the direction of your career, and what impact did it have on your life?
Oh, a lot, for sure. Yeah, I mean, I think all of Brahms' soliloquies about duty and all of Sita's reaffirmation about duty, right? I mean that's, it's self-service. Yeah, so like take the whole Ramayana. I mean, yeah, I think, yeah, so I think so for sure, just the baseline sort of what's kind of the field of possibilities that one considers for their adult life, for sure, very influential. I think the really, yeah, I mean, I think the emphasis on academic excellence, positive character development, and the other one, someone private chat me. It used to be right on the website. Now the website says something else, a community of learners, whatever. No, I mean, I think being, yeah, I think that the whole culture of the place, for sure. And I think the relationship between people, right? Between the students, between the teachers and the students. And then, I mean, I grew up at Mount Madonna. So yeah, so I grew up vegetarian, and when I rebelled, I became vegan, and right. So that probably says it all. I should probably just stop, right? Like if you grew up in a place where rebellion is rebelling against vegetarianism to become vegan, then yeah, that probably says it all.
Well, thank you so much. We do have a question in the chat. It's while it's under Prabha's name, it's really from Usha. So thank you for the wealth of critical information and for your service. If we have time for audience questions, wondering what role there might be for carbon sequestration strategies, such as regenerative agriculture.
Yeah, so like I said during the talk, about less than half of what we've emitted has stayed in the atmosphere in terms of carbon dioxide emissions. So we are getting a huge natural service from the land and the ocean, and so that tells you right there that there's a lot of potential in the carbon cycle for sequestering carbon. I think I mean, to me, I think one of the so there's a couple answers. One is that is the all of the above answer, and so it will require these grand challenges that I described will require all of the above to actually close all those gaps, close the energy gap, close the emissions gap, close the adaptation gap. And I think, and then the other answer is that part of what's really challenging about these problems is that we're not, like, we're having debates about whether we're making progress on the second derivative, right? It's like the debate is about have CO2 emissions peaked, not are they at zero or not, right? And so, so I think for a lot of places, like, are we? Yes. So the short answer to the question is yes, absolutely. And in some places, it's in order to prevent the loss of carbon from to prevent the sinks from weakening. And in some places, it's to accelerate the sinks, I think. And in California, we do have National Working Lands mechanism in our climate legislation. So that is a component of our. It's literally valued. So it's part of the cap and trade, and was kept as part of the cap and trade in the last in the renewal of AB 32. So yeah, the answer is definitely yes, and that's not going to do it on its own, I guess, is what I'm trying to get around to.
It looks like Lisa has 2 questions, if time permits. Lisa.
I have 2 questions. One is that you drew a very clear line between skipping carbon infrastructure in developing nations and kind of the future of the planet. Wondering where we can put our energy as teachers, organization, to make that happen. I know of a couple organizations. I'm wondering if you know about more. And then the second question is very selfish, and I know there's a couple other people maybe wondering this. Where do you see Sierra snowpack 10 years from now? That's my other one.
But I got published on the second one, so I'll stick there. Yeah, I'll talk for 8 minutes on that. Let me find my slides. So actually, when I was literally driving from Purdue out here when we moved, literally, and driving through Utah in July or whatever, 40 hours of listening to Harry Potter and thinking about what research questions, and so we actually on that drive had this thought about basically repeating that, repeating that heat analysis of, like, at what point do you reach like a totally new climate, and repeating that for snowpack in the West, which we ended up doing. And we had a paper on the West and a paper on the Northern Hemisphere. So we're already in a climate where we're getting extremely low years more frequently. And, you know, temperature is kind of unbounded. So you can kind of keep getting records. Snowpack, it's hard to get lower than 0 with the snowpack. So that, you know, April 1st of 2015, when Governor Brown stood out on the brown grass, you know, stood there for the photos for the annual April 1st snow measurement, and there was no snow. Like you can't get less than that, right? So we're in a climate now where the question is really like how frequently, you know, what is, you know, this question of the new normal. And yeah, we're in a new normal and we'll be in a newer normal soon. And so that's a lot, that question is a lot of what we try to figure out, is like how often can we expect these really, really low years? So will there be, I'll say this, we're not gonna go into a climate where we won't have snow, because the elevations are high enough in the Sierras that we'll keep getting snow. But I see Jim Zackos' hand is raised, so I'm just drawing this out. We'll see if we get past time. And yeah, so you will still have snow in 10 years. I think that the thing, you know, Peter Glick published on this in the 80s, and like the benchmark was 2050, and we're basically in the climate that was predicted for 2050, and we can expect continued intensification with variability.
It looks like you have a question from Jim Zackos. Jim.
Professor Zackos.
You have to unmute yourself there.
Hey, Noah.
Hey, Jim, how you doing?
I'm good.
Jim was my professor at UC Santa Cruz. He knows a lot about the carbon cycle and paleoclimate and the modern. What about soils? What about agricultural soils? Go ahead, Jim. I'm evading.
No, the question I have it's a hard question, right? It's one that I'm sure you've thought about. And I mean, for this planet and the energy usage, right? And reducing carbon emissions, and you know, the hard question that people often avoid is about population, right? The world's population and sustainability, right? And can we, you know, with maintaining some standard of living in a very practical way, reduce carbon emissions with the current population? Or is, you know, population control part of the solution to climate change?
Yeah, so I tried to calculate that once. And the paper got rejected like 7 times. And anyway, so when I did the back of the envelope calculation, the gap in like the emissions associated with say the non-OECD countries becoming like the OECD countries in terms of per capita energy consumption and energy portfolio. The gap in emissions between that scenario and the contribution of every country keeping their same emissions as now and just having the population growth in the UN projections, the the consumption gap is about 8 times the population contribution. So that's not directly answering your question, but I guess that's the closest calculation that I've done. That like basically the difference between the 2.5 billion people that are using biofuels for cooking and me is many times the emissions associated with that, even just for the current population, is many times the contribution of continued population without development, basically. And so that's kind of the arithmetic answer. And I'm sure there are more sophisticated calculations than that. I was at a fossil-free Stanford shut down the president's office event. I was not shutting down the president's office, but I was in the quad. And another faculty member who does not study climate change, they said, well, you know, the thing is, like, you just need the world to be, like, really the world can support 100 million people. And then until we do that, until we get down to 100 million people, we're not going to solve this. And I was like, well, there's the ethical part, which I know you're not saying, Jim. I'm not ascribing Bob's statement to you, but two, like, it's totally impractical, right? Like, the bottom line is that, as I think about it, whether it's an ethical perspective or a practical perspective, like there's just huge momentum towards further energy consumption, and that energy will either be provided by fossil fuels or will be provided by something else. And to me, that's really the question for climate change in the next 50 to 100 years, is what is that energy going to be supplied by? Not will it not be supplied?
Yeah, I think it is a difficult question, but I think the third world is actually moving toward energy independence or renewable energy faster than us, right? In some ways. And yeah, the classic example of solar, it's easier to build out solar energy, out in the middle of nowhere than, build transmission lines, to bring in fossil fuel generated energy, right? So
absolutely, and it's easier to do that first than to do it from where we're at. I mean, and when I say easier, I'm ignoring all of the economic resources we have if we wanted to commit to it. But there's a lot of path dependency and a lot of inertia in, so the leapfrogging is an appealing hope, I guess. But there's no question that in terms of the per capita GDP, the per capita emissions versus per capita GDP through time, that we're decarbonizing much more slowly in terms of our development pathway, for sure. So that's somewhat hopeful.
It seems like there is another question in the chat room, and it says, curious why the discussion of diet doesn't enter into the discussion of mitigating climate change.
It does a lot it does a lot, and depending on how you calculate, so usually when we talk about sources of greenhouse gas emissions in class, and we usually do a little poll like before, okay, what do you think the different contributions of different sources are? And agriculture usually comes up from students as being a very big source. And it is a big source if we include the land use change. So land use change has contributed around a quarter of the emissions, and a whole lot of that is for for food production, right? And there's some cities obviously that used to be not cities. But in terms of surface area, I mean, it's really food production. So when you count those embodied emissions, then agriculture is a big contributor. When you count the food itself, it's around 10% of the 9-10% of the U.S. emissions, and a lot of that is from the methane and N2O. So on shorter time scales, it's an even bigger contributor. So there are probably some psychological and political reasons around different, the diet versus other. I think there's a lot of, in terms of people who talk about, not saying who study the sources of emissions, but the people who talk about what to do, I think there is a real pressure towards techno-optimism, I will say, right? Like if someone can promise that no one will have to change anything and the problem will be solved, that's appealing. So changing diet is not, I mean, one of our 5 cars is the least electric, and it's the best one we have. So I'm all for electric, right? I'm all for changing my diet. Being vegetarian is my biggest credibility as doing anything climate affirmative, but that is not my motivation. So I won't claim it, but I think I can tell you that like a lot of the motivation for like Impossible Foods and those companies is greenhouse gas emissions. So and climate change. So I think it. Yeah, I mean the shortest answer is probably that it's easier to propose a solution that will cause no one to have to change anything, just their energy source changes, than there is to change their diet. But that's why you get companies that are basically trying to develop ways that people wouldn't have to change their diet either. They just have to change which box it comes in.
Well, thank you so much for sharing everything with us this evening. I see in the chat there's a lot of appreciation for your time tonight. So from Sarojini, deep appreciation to Suresh and his passion for knowledge that will help the earth and help to educate us on what is really happening. And deep appreciation to the leadership of Mount Madonna School for continuing the path of being globally educated and addressing timely topics. Deep appreciation to the students in these times for continuing to grow, change, find new solutions, and remain hopeful. Love and blessings to all. Thank you this is from Prabha. Thank you so much for sharing your expertise, knowledge, and love of this discipline. What a gift to all of us. And so there's lots of thank yous, and we really want to thank you so much. And for all of the audience, I appreciate you coming and spending this evening with us. And if this was inspiring for you, we do have another seminar, as I mentioned earlier in the evening, on April 22nd. And at this seminar, it's going to be led by Tobias Aguirre, and he is the Fishwise CEO, and he's also an MMS alumnus. And he
was Robin at like 4 years.
There you go. And he was Robin
only
4 years.
Only probably Laura is more.
Oh, well.
And that was back when only one person was Ravana. It wasn't like this 6 people playing Ravana on video or something like that. I don't know.
Hey, now you should come to our Ramayana, the film this year, and see a new version, the film version of this. Now, for next time at Fish Bites, it's going to be sustaining ocean ecosystems and the people who depend on them. So I would really like to give everybody a big round of applause for Suresh. Thank you so much for coming. And we do hope that you come next week. And Suresh, of course, anytime you would like to come, please join us. And anytime you'd like to visit MMS, please do so. All right, thank you so much. And again, please continue following the SDGs on Twitter, Instagram, and Facebook. And if you would like any more information, certainly please check out our websites and please check out different resources so that you can learn more about climate change. And if Suresh might have additional suggestions, I'm sure he would be willing to offer ways for that we could learn more and do more to support climate. All right, well, thank you to everyone very much.